If the sun released a solar superflare right this second, you wouldn't see it coming. But 8 minutes and 20 seconds from now, every screen you own would permanently go black, every hospital machine would flatline, and 300 years of human technology would vanish into thin air. We aren't protected. We're just lucky the timer hasn't gone off yet. Today, we are examining the Carrington Event, solar superflares, and the fragile magnetic shield standing between civilization and total darkness, and what happens when the sun decides to breathe out. Before we inspect the solar detonator, the mandatory rules of the vessel. Fact 1. Today's data comes straight from solar astrophysicists who sacrifice their sleep cycles to stare at blinding plasma flares, none of whom ever got a thank you text from mankind. Fact 2. If your spatial reasoning suffers an existential error halfway through this breakdown, emergency cognitive paper towels are available, virtually, beneath your seat. Before we launch, hit that subscribe button as it fuels our vessel to go on such journeys. To understand how the sun can destroy your Wi-Fi without ever moving a single mile closer, you first have to realize that the sun isn't just a giant ball of fire. It is a churning, chaotic, magnetic engine. Think of the sun's interior magnetic field lines like thick rubber bands stretched tightly inside a boiling pot of soup. As the superhot plasma inside the solar core boils and rotates, it grabs these magnetic rubber bands, twisting and knotting them tighter and tighter until the tension snaps. When those lines snap, they unleash a coronal mass ejection, a solar superflare that hurls billions of tons of superheated plasma, traveling at millions of miles per hour, straight into deep space. Imagine an annoyed neighbor throwing an entire swimming pool of boiling battery acid across the street, except the street is 93 million miles wide. Most of the time, the sun fires these plasma bullets into empty space. But every few centuries, Earth happens to be standing directly in the target zone. How does that make your afternoon calendar invite feel? So why haven't our brains been cooked like microwaved leftovers yet? Because Earth operates its own invisible force field. The magnetosphere. Think of Earth's magnetic field like holding a light nylon umbrella in the middle of a massive hurricane. The umbrella doesn't stop the storm from existing. It simply channels the violent wind and rain around you, keeping you dry inside a quiet, calm bubble. From our point of view on the ground, everything feels completely normal. Your heart beats, your coffee stays warm, and you scroll through social media, assuming the sky is a static ceiling. The magnetosphere deflects 99% of the solar radiation into deep space, channeling a tiny fraction toward the poles, which creates the glowing auroras people pay thousands of dollars to take photos with in Iceland. The problem? Our umbrella isn't made of solid steel. It is generated by liquid iron spinning deep in Earth's core. And when a big enough solar storm hits, it doesn't just bump into our umbrella. It shreds the fabric entirely. On September 1st, 1859, British astronomer Richard Carrington looked through his telescope and watched two blinding white flashes erupt from a cluster of dark sunspots. 17 hours later, the solar shockwave slammed directly into Earth. The night sky across the globe turned so bright that birds began singing at 2 in the morning, thinking the sun had risen. Gold miners in the Rocky Mountains woke up and started cooking breakfast in the middle of the night because the sky was glowing bright emerald green and blood red. Telegraph lines, the high-tech internet of the Victorian era, spontaneously burst into flames. Sparks flew from telegraph keys, shocking operators. In several stations, operators disconnected their batteries completely only to realize the geomagnetic energy flooding out of the sky was so thick the telegraphs kept sending messages across continents with no power attached. Imagine your laptop running at full power while unplugged in the middle of a desert simply because the sky is angry. That was 1859. Humanity had no microchips, no satellites, no digital banking, and no national power grids. We were a wooden civilization hit by a digital bullet. So, what happens when that exact same solar storm hits us today? It triggers a physical phenomenon called geomagnetic induced current. Think of our global power grid like a set of guitar strings, stretched across thousands of miles of land. When a massive solar magnetic cloud hits the atmosphere, it plucks those high-voltage wire strings with millions of volts of raw electricity, forcing that current straight down into ground transformers. High-voltage transformers are the custom-built steel heartbeats of modern human life. They take 3 years to build, weigh 300 tons, and cannot be bought on an online store. When the solar current hits them, the copper coils inside instantly heat up to thousands of degrees and melt into solid slag within 90 seconds. No backup generators, no quick repairs, just hundreds of critical energy nodes melting simultaneously across every major continent. Here is how fast your daily routine unravels when the grid suffers a solar heart attack. Within 90 seconds, the power grid collapses. Your phone screen goes pitch black as cell towers lose power. High-voltage water pumps shut down, and clean tap water stops flowing. Gas station pumps freeze. Refrigerated food supply chains grind to a halt, and digital banking systems disappear, rendering your bank balance completely inaccessible. The sun doesn't need to burn Earth to ashes to destroy human society. It just has to turn off the electricity long enough for us to realize that without microchips, most of humanity doesn't know how to source clean water or food. If you think you can escape the solar fallout by staying offline, look up at the sky. When a solar superflare slams into Earth, the immense radiation heats up the outermost layers of our atmosphere, causing the air to expand outward like a baking loaf of bread. Thousands of critical satellites orbiting in low Earth orbit, GPS systems, weather monitors, and internet constellations suddenly find themselves flying through dense, hot atmospheric drag. Think of a high-speed sports car driving smoothly on a highway and suddenly hitting a mile-deep pool of thick, wet mud. The satellites slow down rapidly, tumble out of alignment, and burn up in the upper atmosphere like falling stars. Without GPS, commercial aviation stops, container ships lose navigation, and the invisible sky threads holding global trade together snap in a single afternoon. The most disturbing part of this entire scenario isn't that a superflare could happen. It's that the sun is on a strict mechanical schedule. Every 11 years, the sun's magnetic poles completely flip. North becomes south, south becomes north, and the solar surface goes from quiet calm to absolute violent chaos. A period called solar maximum. During solar maximum, the sun fires off hundreds of solar storms every month. We are living through a solar maximum right now. Every single morning you wake up, pour cereal, and check your phone, you are effectively rolling a loaded 11-year die against a star that has been throwing plasma fireballs for 4.5 billion years. How does your unread email inbox feel now? When you step outside tomorrow morning and feel the warm sunlight hit your face, it is easy to treat that star like a friendly static light fixture in the sky. We build bustling cities of concrete and glass, lay underwater fiber optic cables across ocean floors, and upload our lives into digital clouds, convinced that our modern world is permanent. But every solar flare, every coronal mass ejection, and every magnetic storm reveals the exact same humbling truth. Humanity didn't construct civilization on an unbreakable foundation. We built it inside a brief, fragile, temporary lull created by an invisible shield of liquid iron. We drew lines between the stars and called them our permanent digital empire. The universe just called it a quiet afternoon between solar storms. Drop a comment below letting me know. If a solar Carrington event wiped out the global power grid tomorrow, how many weeks do you think you would survive? Hit that subscribe button, give the video a like, and I'll see you on the next log entry closed. See you on the next ascent.